Okay, hi guys. So in this video lecture, we'll be seeing some of the more examples on tautomerism. So the first question is, you have to tell me how many of these compounds will actually show tautomerism. So first compound is this one. Second is this one. Third is 2-butanol. Fourth is benzophenone. Fifth is carbaldehyde or benzaldehyde rather. Sixth is a bicyclo compound with these two as the bridgehead carbon, double bond O here and 2 here. Seventh one is 2-butanol. 2-butanol is already covered, so we'd have this structure. Okay, so now as you can see, there is no alpha hydrogen here, so no tautomerism. No alpha hydrogen here, no alpha hydrogen here. There is a alpha hydrogen, but this carbon cannot be sp2 because of the violation of Brat's rule. Here we have a alpha hydrogen, and this will actually make the compound aromatic as well. This will have 2-butanol will have, there is no alpha hydrogen here. Okay, so let us write the reaction mechanism of how as to this compound will actually show tautomerism. So the end compound would be something like this. We would have OHC bond CCH3. So this let us look into the mechanism of as to how this reaction takes forward. So mechanism would be something like, we would have something, this was the original compound, so from this we would have something like this, wherein the O minus will take the electron away from carbon. So now actually H2O will come into the picture. This O minus will attack the H2O and will take, and here actually we will get some positive charge here. And why would we get positive charge here? Because of we'll get a positive charge here indeed, right? Not double bond. Double bond is not present here. So will it take this hydrogen or this hydrogen? It's better to take this hydrogen and have a negative charge here, so that the O can take up its bond. So this would not be an intermediary process. This O minus will take place because of the removal of this H, as OH minus will take this H. OH minus will take up this hydrogen, hence there will be negative charge here. You can say negative charge here, and this negative charge will be there. This negative charge will form a pi bond with this carbon bond, that will result in shifting of pi electrons to oxygen, and the oxygen negative charge form on oxygen will take hydrogen H plus from here, thereby again degenerating the OH minus in the reaction. Okay, so double bond here, OH will take place here, CH2. Okay, so next what will happen is, we would have something like this, wherein negative charge will come on this oxygen, this carbon atom, and with the formation of double bond here, O will get a positive charge and CH2 would be there. oh sorry, this is already taken up by this. Okay, so it would release the again the OH minus, the H2O formed in this case would actually be taking the H2O which was formed as of the taking up of H plus from this OH minus. As a result, H2O was formed, and from that H2O only OH minus was regenerated into the reaction because of this oxygen taking up this hydrogen. Okay, so OH is formed here, and OH minus would be H plus is attached with O plus here, and OH minus will again be regenerated. So what this OH minus will do is, this OH minus, let me write here, so it will attack this OH plus and it will take H plus from here. So we will get something like C minus is here, OH, single bond double bond O, and this will form a H2O. Hence this carbon ion will attack on this to get, or rather collect, H plus here, and it will again release OH minus back into the reaction. So this is the product formed. Okay, so let us talk about the conditions for keto-enol tautomerism. Okay, so conditions for keto-enol tautomerism. Okay, so first is the presence of alpha hydrogen in ketone is a must. Without it, we have seen the example that without it the tautomerism will not take place. Presence of alpha hydrogen in ketone. And what about this example? Means there is no alpha hydrogen here, but in this compound, but still the tautomerism takes place in this case. So why is this the case? This is the case because there is no alpha hydrogen, but still tautomerism is there because it is a dienone. Okay, due to conjugation here, it will take up its enol form due to conjugation. Okay, second point is we should have unsymmetrical alpha hydroxy ketone form due to two different position isomers of OH and O. So this is basically straightforward, so I am not writing it. So let us see an example in the second point to understand it better. So suppose we had the aromatic ring, and attached with it is another ring. We have OH here, let's suppose, and here we have OH minus. So it will now convert into, it will attack this hydrogen, negative charge will be formed here, so it will form a double bond here. Suppose there is a double bond, it will form a double bond here, and then what will happen? What will happen is oh sorry, this H is actually taken up by this, so we will have structure similar to this, plus H2 would be formed. Okay, hence in this case also we would have by the reaction of addition of a reagent called OH minus, we will have something like this, and this carbon would actually get a negative charge because of this. No, not exactly the negative charge. The hydrogen here would where would the hydrogen which is attached here go? So what will happen actually is this hydrogen has also be to be taken care of. So this reaction cannot go in forward direction. Instead, this OH minus should attack this hydrogen first, because this is more acidic hydrogen. Because had it attacked this hydrogen, nothing would have taken place and the reaction would have gone in the backward direction. So this reaction would go in forward direction only when this OX group attacks this hydrogen. So let us see whether this hydrogen would also would work or not. So we would have a negative charge here, and because of this negative charge on this, what we can have is we can have negative charge in conjugation with this pi bond. So what it will do is negative charge will be here with the formation of a double bond here and OH here. Now the H2O molecule formed in this reaction, the O minus will actually attack this H2O and would form something like this. Now again what will happen is due to the presence of this OH minus, this OH minus will take up this hydrogen attached on this OH, because this is the most acidic hydrogen atom which we can get from this. So we would get something like O minus here, double bond here, this OH here. So what it would do is form a double bond here, and a negative charge would be on this carbon atom. So this negative will actually attack on H2O to form this compound. Okay, so with this we get this as our product. So this is also ketoenol form, in which initially we had this as our substrate. Now we have this as our product. This is also ketoenol form. Okay, so with this we end our this lecture, and the next lecture we'll be seeing the replacement of hydrogen by deuterium, and we'll see some of the examples of the same. So till then, good luck and goodbye.